Alright, so this video is going to be on graphing cotangent functions and the basics one. This is video 2 of 2, and so if you haven't watched the first video, go back and watch that on cotangent functions. But this one's going to talk about what happens to a cotangent function when the period changes and when there's phase shifts or horizontal shifts. So let's get into it. So if you remember what a cotangent function looks like, right? A cotangent function starts at 0 and then it has only a period of pi. So it goes from 0 to then pi fourths, pi halves, and 3 pi fourths. Remember, tangent and cotangent both start with vertical asymptotes and then they end with vertical asymptotes. And so you'll have your two vertical asymptotes at the beginning and end, and then you want to put your point in the middle, and cotangent goes up 1 unit to the left and down 1 unit to the right, and then we draw what looks kind of like a cubic function. And that would be how to draw a cotangent function. So let's just talk a little bit about what would happen if there was a horizontal shift. So let's say, for example, I said y equals cotangent of x minus pi halves. Okay, so since cotangent normally starts at 0, if you're going to shift it right pi halves, then your new start would just be at pi halves, positive pi halves, and then the end would just be the period away. So the period of a cotangent function is pi, so we'd add pi to this and it would be 3 pi halves. And then you can find your points in between. Okay? And so really all that it would be is just finding the new start and the new end. But since cotangent starts at 0, normally, whatever the horizontal shift is of the cotangent function, that's where it's going to start. So that'll be where our starting point is, and then we'll add the period to find where it ends. And so the second one would be is, what if there's a period change? Like what if we said y equals cotangent of 1/2 x. So if we said y equals cotangent of 1/2 x, now we're saying that the period is being affected. That's a horizontal stretch. And remember, the period is pi. And so like you did with sine and cosine, where you did 2 pi divided by b, in this case, we're going to do pi divided by b, so we'll do pi divided by 1/2, and then we'd multiply by the reciprocal, so the new period would be 2 pi. Meaning that if we look at the graph, you have 0 to pi there, well, that would be 5 pi fourths, 3 pi halves, 7 pi fourths, and then 2 pi. So here's 2 pi. Now we're saying that if this was the graph, we would have our vertical asymptote at 0. That would be our start, because we don't have any horizontal shift. But then you'd add the period, and now you end up at 2 pi. And so this graph got much longer. And so you could see it would go right in the middle, it would be in the on the midline. Then go up 1 to the left and down 1 to the right. And these would be your points that you'd use. And so then it would be a much more stretched out graph horizontally. And there you have it, right? And so that would be a period change. It would get either stretched out or it would shrink in, and the period would be less than pi. But a couple things to note. If there's no horizontal shift, the start is always at 0. So you're either going to start at 0, or if there's a horizontal shift, it'll start at that new value. And then you're going to add the period to find where it's going to end. And you should be okay. Alright, so just we're going to bring all of these into this video. So remember, that's going to be your vertical shift. This is going to be your amplitude, but it's not really an amplitude, so it'll be our vertical stretch slash shrink, so making the graph become more narrow. And then it also will do reflections if it's negative. B is going to change your period change, right? And make sure that instead of doing 2 pi divided by b, you just do pi divided by b. And then the last one is, remember it's got to be factored, but once it's factored on the inside, that's your horizontal shift or your phase shift. And that's going to be where our graph starts, or at least the start of our first period. Okay? We'll still do the domain and range the same way, where we'll have to pick an asymptote, but the one thing I will say is that if the period changes, then the separation of the asymptotes is going to be different than pi. It'll be the amount of the period. Okay? So here we go. Graph the function y equals 1 plus 3 cotangent of 2x plus 4 pi. Alright? So let's just break it down like we say to do, right? So the breakdown is going to be A, we want to know that. We want to know the period. We want to know if there's vertical shift. We want to know if there's a horizontal shift or a phase shift. And then we'll talk domain and range as well after we've graphed it. Alright, so the A value is 3. Hopefully everybody can see that. The period, we're going to take that 2 and we're going to do pi divided by 2, so it's just pi halves. Now we should probably factor off to the right over here, so 2 parentheses x plus 2 pi. So our vertical shift is up 1, and our horizontal shift is left 2 pi. Alright, and so I am going to do kind of what I've done always, is I'm going to just make a quick x-axis off to the side over here. And I'm just going to see where my graph's going to start and end. So negative 2 pi, and then I'm going to add the period, so that would be negative 3 pi halves. And then I've got to find what's in between, right? So if you want to figure out what your notches are going by, your notches are going by eighths, because if you take your period and multiply by 1/4, you would get pi eighths. So if we want to count by eighths, think about it. 2 is 16 eighths. So this is negative 16 eighths. So this is negative 15 pi eighths as we count towards 0. Then this would be negative 14 eighths, which would reduce to 7/4, right? Negative 7 pi fourths. And then you would have negative 13 eighths. Alright? And so there would be our 5 points. And then if we wanted to do another one, we could just go and keep counting more eighths and find our way there. Okay? Let's put this on the graph. Alright, so as we go to the graph, we're going to put in our midline. So our midline is at positive 1. Y equals 1. There it is. And let's label our axes. Now, you can do a lot of different things, but I'm going to just go by, right? So pay attention. Here we go. This is going to be negative pi. So if you think about it, I'm going to tell you that this is negative 2 pi right here. And then, just kidding. That's not going to work. So let's actually do something a little crazy. I'm going to go and I'm going to say this y-axis that looks like it's there, not going to be the y-axis. Okay? So here we go. It's about to get real. So I'm going to call this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So let's call this right here. And I allow my students to do this. Just tell me that this is my new y-axis, right? Just because it's shifted so far to the left, and my period, right, my notches are going by eighths, just doesn't quite fit on the graph paper that I've got. So I'm going to call this my y-axis, alright? And so then I'm going to go by eighths here, like I said. And so we said that was like negative 2 pi, is 16/8. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this is going to be negative 2 pi, right? And then this is going to be negative 15 pi eighths. And then this one's going to be negative 7 pi fourths. And then negative 13 pi eighths. And negative 3 pi halves, right? And that's 12/8. And so then I'll have 11 pi eighths. And then 10 pi eighths would be 5 pi fourths. And then we'll have 9 pi eighths, or negative 9 pi eighths. And then we'll have 8 pi eighths, which would be pi, negative pi. And that should make sense, right? If the period is pi halves, we should have two periods. Right, we should have two periods from negative 2 pi to negative pi, because the period is no longer pi, but it's pi halves. And if you want to keep making periods, you could, but there we are. All right, and so now we're going up one, right? So up one, and that's where my midline is, and I'm going to put a point right on the middle. And then remember, we're going to go up the amplitude to the left since it's cotangent, and down the amplitude to the right. Up to the left, down to the right. All right, now let's do the domain and range. So the domain, remember, we're going to pick an asymptote. And so if you think about it, if it's always easiest to pick it when the asymptote's 0, if you think about this, this would be 1, 2, 3, 4. So this would be another asymptote, and that's pi halves away, so that would be negative pi halves. And then 0 would actually be an asymptote. And so since I can see that 0 would be an asymptote, it's probably easier to say that x, right, my equation of my asymptotes is going to be x equals, and I'm not going to do 0 plus because it doesn't matter when you do 0 plus, but I'll write it just so you can see what I'm saying. 0 plus, and then the amount of spacing between the asymptotes is the period, so pi halves, and then n, and remember n is an integer. N is any integer. Okay, and so when we do the domain, we're going to say x can't equal pi halves n. Alright, and then the range is all real numbers. Alright, so let's try another one. That got a little crazy. Hopefully this one's a little bit easier. You never know though. So here we go, breaking it down. If you want to hit pause and try it on your own, feel free, and then come back and watch the answer. That'll work out well. Period, vertical shift, phase shift, domain. Alright, so 1/2, but I know I'm going to reflect it. So we're going to reflect over the x-axis. The period, right, so if I factor out 1/4, that would be x minus pi. Right, so the period is going to be pi divided by 1/4. So that's going to become 4 pi. Our vertical shift is up 3. And then our phase shift is right pi. So if we make a quick x-axis, since it's cotangent, it normally would start at 0, so now it's going to start at positive pi. And then the period is 4 pi, so we add that, and that's going to be 5 pi. And if you do our notches should go by pi. So this is wonderful, significantly easier, right? So this would be 2 pi, 3 pi, 4 pi. Okay? And we can plot those wherever you would like. I'm just going to go like this. 1, 2, 3, 4, 5. My notches are going by pi, 2 pi, 3 pi, 4 pi, 5 pi. Alright. Gonna put in my asymptotes. First one's at pi. Second one's at 5 pi. And then our horizontal shift is up 3, but I'm going to make these go by 2 since we have an amplitude of 1/2. So 1, 2, 3. There's my horizontal shift. Okay, and then we're going to put our point in the middle. It's cotangent, so normally you go up the amplitude to the left and down to the right, but since it's reflected, we'll go down to the left and up to the right, and I'm only going 1/2. And there's our graph. If we want to keep making more, we can, but I'll just do one for now for the sake of time. And so the domain, we're going to pick an asymptote. So notice 0 is not going to be able to be an asymptote because the next one would be 0, -1, -2, and then it would be -3 pi, right? Would be the next asymptote. So since they're spaced out by 4 pi, the period, we're going to say x can't equal, I'm going to pick pi as my asymptote, plus 4 pi n. And those are going to be the descriptions of our asymptotes, and that's what x can't equal. And our range is all real numbers. Okay, have a great day.